Hello, my dear thinkers. This is your tinkering master Srinivas from scientificstudents.com. CircuitLab is a wonderful workshop. We have conducted level 1 at Sri Gautami Smart School, Rajahmundry, and today is the last day. So already my thinkers, they have made projects like first project water level indicator, second project automatic street light, third project a clap switch, a sound operated switch. Like instead you press a switch, then the sound itself, the clap itself will make the lamp on. But yesterday I have made them understand the basic circuit, and in the basic circuit I have connected one 12-volt battery and then 12-volt bulb. I made them understand how much current the bulb is pulling from the battery, and they measured through my multimeter around 200 milliampere, which is nothing but 0.2 ampere. Now they have calculated the power of the bulb, that is P is equal to V into I, that is 12 volts multiplied by the current whatever it is pulling to 0.2 ampere. Then they said it is 2.4 watts bulb and all they have calculated. Now today, because my friend Atul has developed this circuit book, so here what we are going to do, here we have a connector like a crocodile clips and all, and we can connect a 9-volt battery. So instead of 12 volts, I am going to connect a battery here. Suppose say this is my battery, and then this is 9-volt battery I am going to connect, and then from there they have a resistor here. Okay, they are using one 470 ohm resistor here, and then from there they are going to connect one switch, and from there they are connected to one LED, and then they are connected back to the negative. So this is anode, this is cathode, this is a green LED. Okay, now if I press the switch, then what happens is that circuit is getting closed, so that's where the light comes on. So we wanted to verify that. And then I will ask my mentees why we have used this resistor. But in the yesterday's case, we have not used any resistor. But here in this today's case, we are using one resistor. Why is that? That's important. So my dear mentees, just check it up. I am going to connect a battery to this particular circuit book, this basic circuit page. Okay, I have connected a battery and it is not glowing. The bulb is not glowing. Can anyone say why the lamp is not coming? Why the LED is not glowing? Can anyone say?
Because you did not on the switch.
Oh, you want me to press here? So my friend also wrote here, press here. Okay. So I have pressed here, and then it is not glowing. Maybe somewhere the negative positive connection. You see? Now it is glowing. Yes or no?
Yes, sir.
So the circuit is closed.
Yes, sir.
That's where. But now the question to all of you, why we are using one 470 ohm resistor here? That's one question. Second question is, how long this LED will glow on this 9-volt battery? Third question is, how much current going on in this circuit to keep this LED on? You wanted to know how much current is flowing through this?
Yes, sir.
Okay, no problem. I can show you that current. So yesterday how we have measured the current? So by connecting that into current reading, so we are going to, that is because LED with the resistor 9 volt, it is in the order of few milliamperes. So how many milliamperes it is taking? That is more important. That's why I am going to check whether my multimeter, why it is not showing 0, now it is showing 0. Now what I am trying to do, because you know that yesterday I have explained my energy source and the current meter must be in series. That's why I have disconnected that energy source and I am connecting, but not showing any current, right? Because circuit is not on. Now I am going to keep my circuit on. Okay. Say why? Oh, battery lose connection? No. So my multimeter in this connection it is not showing. So I am going to change to some other connection. You see now it is showing. Okay. It is drawing very less current. Okay, 20 milliampere current it is drawing. So I want to cross check that with another multimeter so that you will understand much better. That's why I brought few more different multimeters, digital multimeters. Okay. So where to keep this here? So I am going to keep it here and then check through this how much it is showing me, because I want to make sure you will understand how much current is pulled by this LED. Okay. So I am going to press it. You see, now you can see how many milliamperes it is taking. So we can check more precisely. Okay, in the milliampere range, this also is not working. So that's why I'm going to change it out to some other multimeter. So we have another one. Yesterday only we brought it for you guys. So here we have to keep this one and DC ampere. See here, micro 20, 200 milliampere, 10 ampere. So I'm going to put in 200 milliampere range. Okay. Now let me see whether it will show me the proper current or not. Okay. Now what I need to do, the battery connection must be given to my ammeter positive, and then ammeter negative has come here as a positive this. So okay, now if I press this button, see now, oh, this LED is drawing, how much current it is drawing? 14 milliampere. Okay, now you see, I am removing the ammeter from the circuit. Though the switch is on, but the lamp is not on because this ammeter is in series with the circuit. So if it is open means no current is flowing. You understand? So now I can understand how many milliamperes this LED is pulling from the battery. 14 milliampere. Then if you multiply it by 9 volt into 14 milliampere is the power consumed by this. The power of the LED. Oh, you understood? Is it? Now it's a question for all of you. Why are we using this resistor in between? Okay. Now I am clear about it. It is very clear for all of you. So now my dear friends, my dear thinkers, I have another circuit book on a resistor. So here in this book there are two different resistors. LED is same, applied voltage is same here and here. 9 volts only, 9 volt battery. But here the resistance is same. Lesser the ohms, more the current, more the bright. Higher the resistance, lesser the current, lesser the bright. So you wanted to know that? You want to check it? See, I am connecting my battery to my circuit. Though there is no switch, but it is not glowing. Can anyone say why it is not glowing? Have I done any mistake?
Yes, sir, because you get the negative to positive, positive
the
to
back.
Oh, this one, these connections have made a mistake. Okay. So instead of giving it, because the anode is here, okay, so I must give positive from that side, right? Okay, now I'll connect. Is the lamp is glowing?
Yes, sir.
So can you see the brightness?
Yes, sir.
Now I'll change these connections to this place, okay, to this circuit. Okay. Now it is very dull, low bright. You see, almost it is 10 times more earlier. Though it is glowing, but it is just indicating that I am glowing. But you can see the bright light there. You understood? But these are the copper ones. Where are the wires in our circuit? Yesterday we are using all wires. But in this book there are no wires. The coppers are itself are working as a wires. Okay? Copper tracks. In the PC board I have shown you, know. You see? Happy?
Yes, sir.
My dear friends, yesterday my children have made automatic street light LDR as a sensor. So here, you see, now I am connecting LDR, see, it is glowing. See, 9 volt is connected through LDR to the LED and then the circuit is closed, it is glowing. Because some light rays are falling on this LDR, that's where the resistance of LDR has come down, that's where the current is passing through, that's where this LED is getting. Okay, now I am going to block the light rays so the resistance will go up, then the brightness will come down. Now I am going to block it, you see? See, because sun rays are coming from the window side, and if I keep my hand onto the window side, the sun rays falling onto this LDR are coming less and less, and ultimately if I close my finger, see, yes or no?
Yes, sir.
See, if I close the LDR totally, it's like this, and see, yes or no, have you seen that? You can also see through, suppose say, here is a kind of something like this, you see. Now if I close this one, from the top side also, you see, and if I close totally, you see, now there is no circuit, because it's feeling like a night, it's totally night. Dark resistance I have explained you, it's very high in the mega ohms. When there is a mega ohm resistor in between these 2 points, then the milliamperes in the LED are going down, and ultimately they won't conduct anything. Right? You understand? Is it clear to all of you? How the value of the resistance is changing in the LDR? That is why it is called light depending resistance. The value of resistance is changing with respect to the light rays falling on to that LDR. So that is the sensor you have used in your light activated switch. I mean which one? The automatic street light. Hello, my dear friends. Now you see the battery is connected to the bulb, but bulb is not glowing because in between there is another special kind of switch. It's not a regular switch. It's a magnetic reed switch. It is going to read the magnetic energy. So I have a magnet here. So if the magnet comes close to this magnetic reed switch, the inside contacts will get connect. Then the positive will come here and the circuit will get closed and you can see the LED is on. Okay, you see? See? Have you seen? Have you seen or not? See? So when the magnet comes close, you see? Circuit is closed because the magnetic reed switch is on. That's why the battery is connecting here. If you want to see, you can also see through your meter whether you are getting that particular voltage or not. You see, from there also you can see whatever voltage is there here, the same thing. You see, the negative is common. Now the battery voltage. You see, first you see, here is a voltage. 9 volts is there. Here it is not coming. Now if it comes close, then whatever voltage is here, the same thing. You see? You see? Because of that, this is on. Right? Happy? Happy or not? You understood how
Yes,
this works?
sir.
How this
Yes,
works,
sir.
you understood?
Yes,
I'm going to
sir.
give you one today to you all. You have to make me understand how it works, okay?
Okay, sir.
Is it clear?
Okay, sir.
So thanks to my friend Atul for sending you all this, right?
Yes,
Now
sir.
I have another circuit here. This is to make you understand a transistor. Because we have used this transistor now today, because we have used transistor in all the projects. In water level indicator, we have used a transistor with a small signal on the base, connecting collector and emitter, circuit is closed, LED is on and all, I have explained, right? Now we are going to see that, right? You see this way. So I have connected negative to the emitter. So positive I will be connecting here, that is going to the resistor, and anode and cathode and collector of the transistor emitter is getting negative. If at all any signal comes onto the base and these two will get closed and automatically circuit is closed and then you will see the lamp on. Okay. Now I am going to connect the battery positive also to the circuit. But nothing is happening. Is it closed circuit or open circuit?
Closed circuit.
Is it closed circuit or open circuit?
Closed.
Though everything physically looks like they are connected. Physically they are connected, but functionally they are not connected because there is no signal on the base of the transistor. That's why the collector and emitter are not getting connected inside the transistor as a switch. That's why there is no electron flow. That's why there is no LED coming on. So now what I am trying to do, in the water level indicator you have seen that through 100 ohm resistor we have taken a positive signal through the blue wire into the water. Likewise, the 9 volt of this particular track, I have taken it, which one is that? This one. So, that 9 volt I have taken to my body. Now my body has got the 9 volt signal here. If I touch here, you see my dear friends, because this signal is coming to this base of the transistor, when the signal comes on the base of the transistor collector and emitter are getting connected, that's where the circuit is getting closed. You see? Not only me, you can also hold here, hold it. No, this one. You give me one your hand, okay? You go on that side. You take your hand, Likewise, you take, Puneet, you take that boy's hand. You take from that hand. And finally you bring, come here. Take this hand, you bring that your hand here. And then touch the wire, touch the wire. You see, that way the signal is going from my side, you see, to Shashank's, and then from there it is going to, and then Puneet, and then Gautam, and then Nirvigna, and then finally it is glowing. If anyone is open, leave it, leave it. You see, the circuit is open. Anyone is opening in it, the signal is not coming back to the base of it. Is it fun? Happy? You wanted to show it again to the video? Come on, come on, come on, come on for the video. So, yeah, you see? Now open anyone in between. Still earth is connecting, that's why it is coming back. Okay, all of us, leave all of us. You see? But this is how it works. Okay. So my dear thinkers, I am going to show you some interesting thing. You see the LED is on or not? You tell me. 9-volt battery positive is going through the resistance to the anode of the LED, and cathode is getting back to the negative, right? But in between I have connected one capacitor. Because you need to understand, this electrolytic capacitors acts as a voltage storage, energy storage. It stores little energy. Okay? So capacitor is a energy storage here. Now if I remove this battery, then you can see still sometime this LED is on, you see? It is on. It is on for some time. If you wanted to keep it for more time, then what you need to do? If you remove it, then it is coming for 10 seconds. But if you wanted to keep it on for 30 seconds, then what you need to do?
Sir, keep the connection of the battery for a more time.
Okay, see, even if you keep it for 10 seconds or 30 seconds or 1 minute also, it can charge up to the maximum of its capacity. It cannot go more than that. Capacity is limited. 1000 microfarad means it can only receive the energy up to that level only. So that is only helping you for 10 seconds. So if I wanted to keep it for 30 seconds, what I need to do? I can add more capacitors, or otherwise make a big capacitor.
Still 2 capacitors.
Adding another capacitor parallel to this, like adding another battery. Or otherwise go for 2000 microfarad directly. Why unnecessarily adding one more onto this and all, right? So these are all you can understand from your upcoming classes theory, okay? That's how you need to learn. Happy or not? Tell me.
Yes,
so capacitor, how it is working as a storage, okay, like a battery. Now I am going to show you something else more, very more important. This is, here you can understand this way. I want to make you understand how diode works in a circuit, right? You see, if I connect here, this is on. See, the resistance is there, from the positive to the resistance, and anode of the diode, cathode is coming to anode of the LED, and cathode is going back to negative. So this is on. This is not on. Why? Because there is some problem. But if I keep it reverse, if I keep this one here, and if I keep this one here, then this is on, not that one. That means what? The diodes are reversed. The LEDs are reversed. Here in this case, anode is here, cathode is here. Anode is here, cathode is here. But in this case, anode is down, cathode is here. Anode is here, cathode is there. That's why it is getting positive bias. So always we need to make the circuit positively biased. Then only circuits will. So here the positive is going to resistor, and then positive bias is nothing but anode of the diode, and cathode is coming out, and it is going to anode of the LED, cathode is going back. So this is positive bias. The diode and LED both are positive bias. That's why this is glowing. And if you are reversing, what's happening is that second circuit is getting positive bias. Okay, this fellow is getting positive bias, not that fellow, because that fellow is getting reverse bias. That's why it's not glowing. This is positive bias. You understood? Is it clear to you or not? Tell me.
Yes, sir.
See, my dear friend, this is a variable resistor. This is a variable resistor. See, with this screwdriver, I am trying to do something here. See what's happening, you see. I am turning this side. So which is more brighter? Tell me, which is more brighter? This is more brighter. If I am turning to that side, which is more brighter?
This one, sir.
You see, which is more brighter? So how this variable resistor is helping. If I keep it in center, both are equally bright. You understand? So I am changing the resistance, decreasing or increasing onto this side or increasing or decreasing on that side with one variable resistor. I am able to make you understand how it works, right? You see? You see? Yes or no?
Yes.
If I keep it in center, both are equally. That means half the resistance is to this and that means both are equally on. Right? You see? This is more brighter. You understand?
Yes, sir.
So you need to understand how the variable resistance works. I think with this I have explained you few circuits through the circuit book. Okay? Made by my friend Atul. Is it clear or not?
Yes, sir.
Okay, now. Hello, my dear mentees. This is your mentor Srinivas from scientificstudents.com. Here on this 10th May 2025, so we are enjoying, with my mentees all about a basic circuit with a magnetic reed switch so that they can understand the subject in a fun way. Because already you know that I always add a lot of fun in all my mentoring sessions. So what we have done is, we have connected one 9-volt battery and then switch and then the regular resistor, current limiting resistor, and then everything is connected. But even the switch is on, the lamp is not on because the magnetic reed switch in between we have introduced. That's why what I am trying to do, I have a magnet here, so I am going to take the magnet close to the magnetic reed switch. Then you see the magnetic reed switch is on because of the magnetic energy, magnetic force. So magnetic energy is offering magnetic force because the force exerted by the magnetic force is making the reed switch on. That's why the circuit is closed, my dear friends. So this is how we need to. So I hope you all understand
Yes,
the basic
sir.
circuit well.
Yes, sir.
Very good. Okay.